Hi friends, welcome back. So today we are going to continue our telecom series. Today's syllabus is multiplexing, mux and demux, FDM, TDM, even and mux. These are the very important for the transmission purpose. So starting with the multiplexing. Multiplexing is the process by which we are combining various signals input, and after that we are combining it and making it one signal, so that it could be easy to transmit that one signal having multiple signals through the media and communication. So starting with the FDM, that is frequency division multiplexing, we have here different message signal modulate different carrier frequency. Then we have TDM, that is standard time division multiplexing. Here we have different signals use different time slots, and this concept used in GSM. Then we have statistical TDM, that is statmex, having dynamic allocation of bandwidth. Now talking about the wavelength division multiplexing, here different wavelengths combined in a single fiber. We can refer this in optical fiber networking section. This is the technique where we use in DWDM concept for wider transmission of the signal through long distance. So most of the companies, telecom, TSP and ISPs, they use WDM concept or DWDM, dense wavelength division multiplexing concept, for transmission of various optical signals and connecting different cities through this equipments called muxes. We talk about the mux and demuxes. At transmission part, there is a CP, customer premises equipment, and mux, and then we at receiver side we have demux and again CP. So generally CP and muxes are of any vendor OEM like Tejas, Huawei, Tel Labs, Ericsson. There are so many vendors are there. So in this diagram we have seen that the lines connecting the CP and the muxes and interconnection between mux and demux. So these are are not line, they are the media or a communication link that is called optical fiber. So these are the optical cables in patch codes, they are interconnected with each others. So in this diagram we can find that we are taking so many signals from the CP various users and combining it to the mux, and after one mux we are sending it to the transmission part of receiver side where we are using demux and again converting it to individual users. Let's have an example. We have user 1 at Delhi and mux is also in Delhi. Now the user 1 is going to mux of Delhi and going to the demux through the various mode of communication which is in Mumbai, and again it will goes to user 1 who is sitting in Mumbai. So we are connecting user 1 at Delhi to the user 1 at Mumbai. So let's have a look on this FDM, frequency division multiplexing. Analog multiplexing is there. We have the voice signal range between 300 to 3400 hertz. We are using balanced modulator for modulating this signal, producing SSB-SE, that is single sideband suppressed carrier AM. Then we use LSB filter, lowest sideband filter, and we have the range now 104.6 to 107.7 kilohertz. We are now using adding and a group filter, and we are getting the FDM output. So we have how many channels are there? We have 12 signals. We are taking and adding it and converting it to one signal, that is FDM baseband. Generally in E1 we have 32 time slots. 30 are normal for the communications purpose, 2 are for the handshaking purpose. So as we know that there is 64 kbps for each time slots, and we have 32 time slots. If we multiply this 32 by 64 kbps, we will get 2048 kbps, that is 2 mbps. So in this way generally 1 E1 become equal to 2048 kbps, that is 2 mbps. So we can see that in TDM, standard time division multiplexing, we use the time frame for carrying our data voice signal through these individual time slots, and we can see that from one side to other side they are using time slot for carrying this signal. For detailed elaboration of this we will continue this into next video.